Hello everyone, this is Onik. I am from Shanghai Jiaotong University. So today we are talking about graphene. You may have heard it's a wonderful material, actually wonder material. But what does that actually mean? Let me explain to you in the simplest way possible. So this is graphene, the picture you can see. It's look like a honeycomb, all hexagons connected together. Each corner of this hexagon you can see in the picture is a carbon atom, and each carbon atom holds hands with the three neighboring carbon atoms. That's it. That's the entire structure of graphene. Just one single layer of carbon atoms arranged in a hexagons. Now here's the most important part. Every amazing property of graphene comes from this simple structure. So remember this slide, we will come back to it again and again. So look at the comparison. On the left is graphene, just one single layer of carbon hexagons, and on the right, what you have your actually pencil lead, graphite. So graphite is just hundreds of thousands of layers of graphene stacked on top of each other. That's the only difference. So let's talk about graphene's property. Graphene is about 200 times stronger than steel. That sounds unbelievable, right? So a one atomic thick sheet, how can be stronger than this steel? So what's the reason? Look at the hexagon on the right side. Each bond between the carbon is a covalent bond. That's a very strong type of chemical bond. So only that's not the only reason that they have very strong chemical bond. The hexagon shape distributes force evenly. If you pull one bond, the entire network resists, not just the one bond. It's like a fishing net. You pull the one point, the whole net holds. In steel, the atoms are arranged differently. So in that case, actually graphene wins. So the conductivity of graphene. So graphene conducts electricity better than copper. We know the wires we are using, it's actually copper made, but graphene surpasses the conductivity of copper. So why is that? Each carbon atom in graphene has four electrons, right? So three of them are used to bond with neighboring carbon atoms, but the fourth electron is actually free, so it doesn't belong to any specific bond. That the free electron can move anywhere across the entire graphene sheet without any barrier. So very very fast. So when we apply voltage, this free electrons just flow, no resistance, no obstacles. So that's why it gives such conductivity. So here's a deeper why. In most materials, electron needs a little push, some energy to start moving. The energy gap is called band gap. You know that already, I hope. In graphene, there is almost no band gap. The energy bands actually touches as a single point. Scientists call it direct point. We will not discuss it now. So why does it happen? You can see in the picture in the green arrow, this electron just passes through along the layer without any feeling any restriction type of force. But when we talk about bulk graphite, where we can see there are many layers of graphene stacked one upon another. So if I want bulk graphite layer to be conductive, it's not very much possible, because when electron moves through it has to go one layer to another layer. So it have to uh, pass or overcome the resistance force between the layer. It have more collision, so it gives us less conductivity. So graphene is also nearly transparent. Why? Because it's just one atomic thick, we have already mentioned. So for light, there is almost nothing to hit. In fact, a single layer of graphene absorbs only 2.3% visible light. Okay, so actually, we can apply it in making transparent transistor skins, flexible solar cells. We can have electronics, we can just see through. Though it is nearly transparent for visible light, it actually absorbs UV light. It absorbs 30 to 40% UVB. That's the dangerous part of sunlight that causes a sunburn or skin damage. So why is the different? Because UV light has a specific wavelength, about 10 to 400 nanometers. That wavelength carries energy that matches exactly what graphene's electron need to jump to a higher level. So you can think like a tuning fork. If you hit the right frequency, the fork vibrates. Otherwise, it doesn't vibrate. UV light is the right frequency for those graphene electrons. but the visible light, the wavelength of visible light or the energy of visible light does not matches the energy required for electron to move or to vibrate. So visible light just passes through, but UV light got absorbed. So it also show us tremendous barrier properties. Almost uh, no atoms can pass through it. So why is that? But the common thing, people may think that the hexagons holes are so small for atoms, to pass through. But that exactly not the case. For example, if you talk about helium atom, so it's very small, smallest atoms. So they are also smaller than the hexagon holes we can see in the right side of the picture. But they also don't pass through the graphene. So why is that? Because there are electron cloud above and below the hexagons. So each carbon has a cloud of electrons buzzing around it. That electron cloud creates a repulsive force, like a force field. So when a gas atom tries to pass through it, it gets pushed away before it even reaches the hole. So graphene can, block oxygens, moisture, corrosive gases, even though the holes are technically big enough for some atoms. So actually, it's because of the electron cloud, not only just the hexagons holes. So here we can see we'll talk about RGO basically, which means reduced graphene oxide. So perfect graphene, the one we have been discussing, is expensive and hard to make in large amounts. So scientists found a shortcut type of thing. They start with graphite, then oxidized it with different kind of strong acids, and get something which is called graphene oxide. You can see in the middle. Then they reduced it. So when I reduce the graphene oxide, it removes most of the oxygen and we get RGO. So RGO is not actually a perfect graphene. It has defects. It still have some oxygen left, but it is cheap and you can make a lot of it, and it's kind of conductivity, better conductivity. It shows better conductivity. Obviously, not as good as graphene. So graphene oxide has oxygen group, which I have already mentioned. So it's water soluble, but not very conductive. So, but it is good for different chemical reactions. And for reduced graphene, most oxygen removed, not water soluble, but reasonably conductive. So we can use it batteries, sensors, coatings, or different kind of composite. And we have already talked about perfect graphene with no defects, no oxygen at all. So it is very conductive, but it actually expensive to make and hard to scale. So uh, now, after all these amazing properties, you might be wondering, how did anyone first make this single sheet of carbon atom? So the answer is surprisingly simple. Let me tell you. So in 2004, two scientists actually synthesized graphite through a piece of Scotch tape. They stuck the tape onto the graphite and peeled it off. So some graphite flakes stuck to the tape. They folded the tape and peeled again. So the flakes got thinner. They repeated this again and again and again. Eventually, they got the flakes that were just one atomic thick. That was the first graphene. 6 years later, they won the Nobel Prize, and all because of this Scotch tape. So that's graphene we have been talking about, and now you know. So if it's new to you, you go tell someone. And I assume you are just new to you are very new to material science. Otherwise, you will not watch my video, obviously. So use the Scotch story and tell some of your friends. And this is Onik, and this is Learn and Relay. Bye bye.